Chemical equilibrium. Physical processes and chemical reactions are part of our daily life. It is a common observation that many physical processes and chemical reactions exist in the state of equilibrium. At equilibrium, the rate of forward reaction and the rate of backward reaction are equal. The effect of concentration on a system in equilibrium can be predicted with the help of Le Chatelier's principle, which states that if a system at equilibrium is subjected to a change of pressure or temperature or number of moles of the component, there will be a tendency for a net reaction in the direction that reduces the effect of this change. According to Le Chatelier's principle, when the concentration of any one of the reactants increases, equilibrium shifts in the forward direction. Similarly, if the concentration of any one of the products increases, the equilibrium shifts in the backward direction. In the case of equilibrium between ferric ions and thiocyanate ions, ferric ions react with thiocyanate ions at room temperature and pressure to form deep red-colored ferric thiocyanate complex. The equilibrium constant for this reaction can be represented as K is equal to the concentration of ferric thiocyanate complex divided by concentration of ferric ion into concentration of thiocyanate ion. The change in the concentration of any one of the species affects this equilibrium. Our aim here is to study the shift of equilibrium between ferric ions and thiocyanate ions by increasing the concentration of either of them. Materials required: 0.1 molar ferric chloride solution, 0.1 molar potassium thiocyanate solution, 0.1 molar potassium chloride solution, distilled water, boiling tubes, clean 250 ml beaker, and measuring cylinders. Procedure: take 10 ml of 0.1 molar ferric chloride solution using a measuring jar and pour it into a clean beaker. To this, add 10 ml of 0.1 molar potassium thiocyanate solution using another measuring cylinder. A deep red color is obtained due to the formation of ferric thiocyanate complex. Dilute the deep red solution by adding 50 ml of distilled water. Place 4 boiling tubes labeled as A, B, C and D in the boiling tube rack. Add 10 ml of the deep red solution to each of the 4 boiling tubes using a measuring cylinder. Add 5 ml of distilled water into the boiling tube A, 5 ml of 0.1 molar ferric chloride solution to boiling tube B, 5 ml of 0.1 molar potassium thiocyanate solution to boiling tube C and 5 ml of 0.1 molar potassium chloride solution into boiling tube D. Shake all the boiling tubes well. Now take the boiling tubes A and B and compare the intensity of colors in the boiling tubes. The red color in the boiling tube A taken as the reference. Similarly, compare the intensity of the colors in the remaining boiling tubes with the color in the reference tube A. Record the observation in a tabular column. From the observation, it is clear that the intensity of red color corresponds to the concentration of ferric thiocyanate complex, and if the concentration of this ion increases, the color intensity will also increase. Increase in concentration of either of the reactants, ferric ions or thiocyanate ions, results in the formation of more ferric thiocyanate complex and shifts the equilibrium in the forward direction. The increase in the concentration of potassium ions due to the addition of potassium chloride affects the dissociation of potassium thiocyanate. As a result, the concentration of thiocyanate ions and the concentration of ferric thiocyanate complex decreases. Thus, the equilibrium shifts in the backward direction. Precautions: use boiling tubes of almost identical diameter. Dilute solution of thiocyanate should be used. The intensity of color of a solution should be compared by keeping it side by side with the reference solution.